See here, as you have already known about priority encoder, what is a priority encoder, how to write a code for that. Okay, now I'll be explaining using for loop. Okay, using for loop, how you are going to write this priority encoder coding. Say first of all you have to know what is your IC and how many inputs it is going to take and what are the outputs it is going to produce. All that you have to know it, right? As you know that it is like enable input. If this enable input, see here, if enable input is equivalent to 0, it indicates that you are enabling this circuit. Okay, as this is active low. Okay, as this is active low, if EI is equivalent to 0, that means this chip is ready to take the input and provide the output. Okay, if at all EI is equivalent to 1, what happens then? If at all EI is equivalent to 1, what happens? Whatever the input you will be giving, output will be asserted with 0. Right, and next again comes under your inputs. All the inputs are with active low. At the same time your outputs are also like active low. Okay, this is what your 8 to 3 encoder. Okay, it is like 8 to 3 priority encoder. At the same time, if you see here, this is your E0. E0 indicates your output enable. That means, see, if suppose there is no output, there is no input present. Suppose EI is equivalent to 1 or else EI is equivalent to 1, it means you are not enabling your inputs. Okay, that means you are not accessing this chip. Then obviously E0 will be 0. That is, see here, E0 is just used for cascading purpose. E0 is used for cascading purpose. That means your inputs are not available here, so you will be going for the next chip if there is any inputs that is available in the next chip. Okay, again it will check whether E0 is equivalent to 0 or 1. If enable input is equivalent to 1, that means output enable is equivalent to 1, that means you are active low, right? So if it is equivalent to 1, that means there are no output assigned here to get that output. So again we'll be using to the next IC. That means this is used for cascading. Okay, so if at all enable inputs are not available, so it will check for next IC. Okay, there also the outputs are not available, it will go for the next IC, like that. Okay, this is your group select. GS is nothing but your group select. See, group select in the sense, it is also called, like, easy to remember, it is like got something. That means you have assigned one of the inputs, like one or more. If you are assigning one or more of your inputs, then group select will be 0. GS bar will be 0. That means you have got something from the input. Okay, if at all group select is equivalent to 1, it indicates that there is no inputs assigned to this IC. Okay, because for that reason this is called your group select, or else you can call it as like got something, that your inputs have got something, that's why GS bar will be 0. This is all about your IC inputs. Okay, now let us come to see here how the coding will be writing for this priority encoder. As of your textbook, okay, you can write the code in any way, but as of your textbook I am explaining this code. Right, library use IEEE, that all the packages you will be writing. Right, next here you will be telling about your entity declaration. Entity declaration comes under here, whatever the inputs, what are the inputs that are available, what is the outputs, that is all you will be indicating your entity. See here, entity EI of L, that is nothing but this one, this is EI of L. Okay, that is in std_logic, that is I of L, that is nothing but your inputs, that is standing from 7 down to 0, that is I7, I6, so on to I0. At the same time, AL is nothing but your output. Output is ranging, it is taking like 3 bits, like A2, A1 and A0, 0, 1, 2 vector. Whereas here E0 of L, which indicates your output logic, that is output enabling here. This is your E0 of L. At the same time, GS of L is also your output, that is group select. Okay, your entity declaration, it has end. Now comes under here architecture. Architecture, see here, in this code you will be using all active high. See, you can write the code either in active high or either using active low. You can use any of the thing, right? Now I am using like active high. You all know about how to write for active low. Now I'll be writing the code for active high. See here, this is your truth table, right? Ranging from I7 to I0. Okay, output is ranging from A0 to A1 and A2. And you have output enable, that is E0, as well as group select, that is GS of L, and output enable E0 of L, and input enable, that is E of L, I of L. See, according to this truth table, we will be writing this code. Okay, and at the same time, see here, these are the intermediate signals. Signal EI is your std underscore logic. See here, signal I is nothing but signal std underscore logic underscore 7 out to 0. See, these are used for the internally generated signals. Okay, I may use these signals. Okay, that is what I am specifying here. If suppose enable input is equivalent to 0, that means you are not enabling that IC. If enable input is equivalent to 0, as you have known, right? Enable input is equivalent to 0, so whatever may be your inputs, outputs will be 0. That means you are not enabling your IC. Whatever your inputs, you are getting outputs as 0, as well as group select. That means you have not got anything. Okay, that's why group select is 0, and output enable, that as your inputs are not available, you are not enabling that IC. See, this is especially used for cascading purpose. Suppose there are 5 ICs. See here, there are 5 ICs. Okay, I want to use this particular IC, or else suppose I want to use this particular IC. So what I will be doing, I will make enable input is equivalent to 0 for this IC, and enable input is equivalent to 0 for this IC, and enable input equal to 0, and I make this enable input is equivalent to 1. So I can access only this particular IC. Okay, right here the same is applicable here also. See, I am making enable input is equivalent to 0. That means enable input is equivalent to 0, so you are not accessing that IC. So directly outputs will be 0, and group select will be 0, and output enable. That means you are using for a cascading. So you will be checking for the next IC. Okay, is there any IC? If suppose, see here, if enable input is equivalent to 1, you are enabling that IC. If you are enabling that IC, then it is like priority encoder. So it will start checking from highest priority. That it is, see here, it is like 8 by 3 encoder. This is 8 by 3 encoder. So it starts checking from I7. So if suppose this is 1, as I7 is 1, it doesn't check remaining all other inputs. As I7 will be 1, it provides 111 as your output, and as well as group select. That means you have got something as your input, so group select will be 1, and output enable will be 0. This is for active high inputs. Okay, as I have already said about active low, now I am discussing about active high. If suppose you are making enable input is equivalent to 1, you will be checking from the highest priority, that is I6 is 1. So if I6 is 1, it doesn't check the other inputs. If I6 is 1, it directly converts its inputs to 111, that is 110, and group select is 1, and output enable is also 0. That means you have got your output, so group select is 1, and cascading, you won't be checking for the next IC. Okay, as your outputs are available in this IC, you won't be checking for the other IC, so output, cascading output will be 0. Okay, see, this is the same truth table that all lies about. From this truth table, how I am going to write it down? Okay, I am going to write it down. See here, now begin process. Process means you will be writing whatever the inputs, like active low inputs as well as internally generated signals, all that you will be mentioning here. Variable j, integer range from 7 down to 0. Okay, see here, begin. If you see here, you are taking only 2 inputs. Okay, those 2 inputs are converted into active high elements. Okay, active high, that is EI of L, and I of L is converted into active high. See, you are converting your active low input signals to your EI and AI. That is your inputs, enable input, that is enable input you are converting in from active low to active high. See, this is called you are converting your active low. See, because why? Because IC is taking your active low inputs, but now I am writing the code for active high. So just I've been converting it to like conversion. Okay, see here, if E0 is equivalent to 1, or else see here, you may not be worrying about these two lines. If suppose you want to write this code for this particular truth table, you can write it like this. Okay, see here, if E0 is equivalent to 1, that means your output is enabled. Your output is enabled. See, E0 is equivalent to 1 and GS is equivalent to 0. See here, this first row. In this first row, if you see here, E0 is equivalent to 1, that means it is used for cascading purpose. If GS is equivalent to 0, so whatever be your inputs, you are assigning your outputs to 0, 0, 0. So that is what I'll be mentioning here. The first row, if you see here, output is equivalent to 1 as well as GS is equivalent to 0. That means group select, you have not got anything. GS indicates here you have got something, right? If GS is equivalent to 0, you have not got anything, so your output will be A is equivalent to 000. Okay, next comes under here, if enable input is equivalent to 0. Okay, if enable input is equivalent to 0, it checks for the enable input. Okay, if suppose enable input is equivalent to 0, obviously it doesn't check for all the inputs, it will be assigning E0 value to 1. Okay, next comes under here, else for j down to 0. Okay, if I of j is equivalent to 1, it indicates that it starts checking from the highest priority. That means it will be checking from the I7. If I7 is equivalent to 1, okay, it will provide 111 as your output. If I6 is equivalent to 1, it will provide 110. In the same way, it will be checking for, see, 7 down to 0. I ranging is from 7 down to 0. Suppose in the loop, first it might be taking I7. Okay, it will be checking if I7 is equivalent to 1. Okay, yes, it is I7 is equivalent to 1. Then it will check for GS is equivalent to 1. Then obviously it will assign. You have got something, that is why you have kept GS is equivalent to 1. I'll be repeating one more time. See here, as J is ranging from 7 down to 0, that means it is like for loop. Okay, it is like for loop, so it takes each value at a time. Like J value will be 7, it checks for J7. If I of 7 is equivalent to 1, yes, as I of 7 is equivalent to 1, then it will assign GS value to 1. It will assign GS value to 1. Yes, I have got something input, so I will be assigning GS value to 1. At the same time, your output enable should be equivalent to 0. Okay, so you are not using for cascading purpose, so you are making output enable to 0. At the same time, see here, A is equivalent to conversion std underscore logic underscore vector of j down to 3. That means it indicates that, see, it is just converting its input. If j value is 7, so here if you see here 7 comma 3, it indicates that it is converting 7 into its decimal equivalent, that is binary equivalent, that is 7 is nothing but 421 code, like 111. So 111 will be assigned to A. Okay, it automatically converts. If again it will check for I6. If at all, if I6 is equivalent to 1, then what happens? GS is equivalent to 1. It will convert 6 to 3 decimals, 3 bits. Okay, it will convert 6 into 3 bits. 6 to 3 bits will be 110. So your output will be 110. Okay, like that. So that is the main function of this. You are converting, like convert std underscore logic underscore vector of j to 3 decibels. Okay, 3, right? Your program has finished, right? That is what you want to mention it, right? Exit and end if. This is your end if. Okay, this is your end if, and end loop. Again you are mentioning end if. Okay, so your program has come to end. Now again see here, as your IC outputs are available in active low. Okay, in the entity declaration you have mentioned your E0 of L, G0 of L and A of L. Okay, so that's why you are converting your active high inputs again to active low. So not of E naught will be assigned to E naught of L, not of GS will be assigned to GS, and not of A will be assigned to active low. Okay, end process and behavior. So this is coding about like for priority encoder, 3 to 8 priority encoder. Okay, see, instead you can write the program as if you wish. Either you can write the program in active high or active low, no problem. Suppose you want to write it in active high, we no need to mention these 2 lines and no need to mention these 3 lines also. But as of the textbook they have given me like this, so I've been explaining all these things. Thank you.